I mean, come on. Where do we go from here? Let's focus first on cleaning up how the code's written ever so slightly. Okay, so let's just accept the fact that we want to blink this thing once a second. Okay, I'm going to delete all these other copies of the blink function. Okay, and ultimately this blinks for 1 second. Okay, cool. Save that. But it's but there are some programming. There's a word I'm going to use probably often. Right now I'm blanking on it, but just some general practices or common practices we'll go with right now. There are some programming practices that are not in place here. Okay, so specifically, and there's two actually. They're the same practice, two different places. So it's using straight numbers, okay, within the body of your code. Okay, so what we have here is setup, and we have a loop. Okay, and you want to like set up a bunch of stuff. You want to like initiate a bunch of global variables, and they're going to be using the loop that you can change at the top of your code or somewhere convenient. It could also be in a different file, somewhere convenient, and then use references to those numbers throughout the body. Okay, ultimately, it's so that if you end up changing physically what pin you're using on your Arduino, you can change the number reference one time in one file, and it will change it everywhere. So you're not looking for the number 13 everywhere, because that could become a problem. Okay, and if you're not really picking up what I'm saying, I will show you and kind of try to describe it better as I go. Okay, so right now we set pin 13 to an output, and then we write pin 13 to be on and pin 13 to be off. But why don't we give pin 13 like a name? Okay, so before the setup, you can do something called create global variables and bring in libraries. Okay, so in order to create a variable, which we have not done yet at all, okay, you have to first pick a variable type. And in the Arduino language reference, there's going to show you all the different types of variables. Okay, but let's just look here. What is a variable, right? Let's just start, and I like to do this and give a, okay, a variable is a symbol. Oh, look, all of a sudden we're doing math. Variable is a symbol that represents a value or data that can change or vary. Variable, it can vary, right? It acts as a placeholder for a value, okay? Whether it's unknown, like in math, or measurable, like in temperature, or a storage container for data in computing. And that's where we're at, right? I mean, really, it can be all the above, right? It allows for general statements and formulas and flexible data storage, making complex ideas manageable, okay? So we're going to create a variable. In here, there's a bunch of variable types, data types, okay? And one of the most common is integer. Integers are literally whole numbers, right? Negative and positive whole numbers like we learned in math class, all right? So an integer can be like 3, but 4.2 is not an integer. 3/4 is not an integer, but 4 is, 256 is an integer, right? Whole numbers, negative and positive ones, okay? So, and it even tells you like how big those integers can be on the Arduino, right? Okay, like you can't have an integer that's greater than 32,767. Okay, and that's because it's in 16-bit system and all this. Okay, you can use a double to create bigger numbers, right? But an integer is limited to these values. Pin 13 is well within the range. Okay, and it represents whole numbers. 13 is a whole number. Okay, so we're going to create a variable integer. I literally type in the word int and press space, and then I type in a word that gives the variable meaning, right? So I could call it LED pin. Right? Why not? Okay, LED pin. And I'm going to say LED pin equals, I'm going to assign this variable a value, 13. And then I'm going to end with a semicolon, because that is the syntactically correct way to end a statement. Okay? And in this case, a variable assignment. Okay, so we have initiated a variable. That's initiating a variable can be as simple as just that line right there, int LED pin. It means, hey, it exists. Okay? And assigning a variable can be the next line, LED pin equals 13. Okay, so we initiate a variable. Hey, LED pin is a variable that exists. Please create a memory storage location for this variable. I'm going to use it. Okay, and then please assign the data inside that memory location a value 13. Okay, decimal 13. All right, you can initiate it and assign it in one line of code. Initiate and equals 13. Now, I can put this variable name wherever I have the number 13 in my code, wherever I want to use the number 13, or more, better said, reference the LED pin. So I want to reference the LED pin here. I want to say pinMode LED pin is an output, and I want to write the LED pin to high and turn it on. I want to write the LED pin to hello and turn it off. Okay, so now instead of putting 13 here, I'm putting LED pin, both doing two things. One, allowing me, the user of the reader of the software, to know, hey, I'm turning the LED on. Like, it's so simple. If I read this line of code here, I'm turning the LED on. That's what I'm doing. Like, that's my interpretation of this line, is I'm setting the LED pin to high, turning it on. Okay, here I'm setting the LED pin to low. Cool. Way better than pin 13, because pin 13 could be attached to a motor. But now I know it's attached to an LED. Unless I accidentally attach it to a motor, right? And if I ever change where my LED pin is associated, like connected to, let's say I change it to pin 11, I can just write 11 here, and it changes it automatically, because now those are going to reference pin 11 instead of pin 13. All right, we'll make that matter in a second. Okay, and that's that, right? Like that's a better practice to assign a value to a variable and use the variable within the code. And this still does the same thing. Watch this. Upload. We effectively didn't change anything in the function of the code. This LED is blinking. Once a second. It's on for a second, it's off for a second. So it blinks. I suppose you could say it blinks once every 2 seconds. Okay. Yay. We could do this for one other thing in this code. We could create a delay. But you can't name it delay, I don't think, because like delay is this, right? But you could say like blink timer or blink, like blink delay or something. Maybe there's even a better way to name it. I will point out that for some reason, I like to do what they do here is I do lowercase first word and then uppercase the second word. Blink delay, LED pin, and I'm going to say 1000. I'm going to assign the value 1000 to the blink delay. Get this out of the way. And then where I delay, I'm going to say delay for amount blink delay. Like maybe call it blink time or blink timer or delay timer or something, right? But effectively, now this is not going to change anything. Also, when you change something when you're programming, like run it. Like if you can, unless you know you broke something, then you have to like still do several things to fix it. Change as little as possible each iteration, and then run it and see if it works. Because if you change 10 things and it doesn't work, now you got to troubleshoot 10 things. If you change one thing and it doesn't work, you troubleshoot one thing. So this still is working. We still have the LED blinking. Okay, and now the obvious thing is like I could change this. Let's change it to like 100. Okay, and then run it. Look how fast it blinks. Look how fast it blinks. It's blinking so fast. Okay, and notice I did not have to change. I didn't have to change this to 1000 here from 1000 to 100 and change this from 1000 to 100. Now I just change it once here, and wherever this is, it references back to what value it is. Ta-da! So we have LED pin with a blink delay of 100 milliseconds or a tenth of a second. Ta-da! Cool. All right. And that's that. Took an hour and 40 minutes. But we're blinking LED. Very, very good. Okay. I'm feeling it. So, where do we go from here? All right. Well, what if we did a couple things? What if we, one, copied this code? I just selected it all by dragging, hitting Control and C at the same time. And I'm going to go to Tinkercad real quick. Here's Tinkercad, okay? I'm going to obliterate all of these things. Potato battery. I have an Arduino out here on Tinkercad, okay? It has the same LED. I'm going to write my code into here. I just pasted my code. I'm going to start the simulation, and guess what's going to happen? It's blinking that LED. Beautiful. I could have done everything I just did in here from the start, okay? If I change this, I can stop simulation, change it to 1000. Look how slow it's blinking now. Beautiful. Beautiful. All right. Stop the simulation.